This is one of the 6 vehicles that we are going to be using for the TORUS project. This vehicle in particular has sort of 2 missions. The most obvious mission is the LiDAR that's mounted on the top of this vehicle, and that LiDAR emits a short-range laser pulse, and the idea is to measure, turbulent structures, wind fields, things like that in the near field. Predominantly, it's been used to look at boundary layers, the layer basically closest to the surface, and how we see the wind evolutions and turbulence and things. It's very important for aircraft, for example, if you're trying to land a plane. There's a lot that goes into those sorts of observations, but we're actually going to use this tool to get closer to severe weather and supercells to see what kind of environments are actually feeding into the supercells. The problem with that is that it's a very sensitive instrument. It's got a laser, it's got parts that rotate and move. We can't shake it apart. So we have to find a way to mount that to where it's not only reachable and usable, because they have to keep it level, but also that it's not going to vibrate. It's not going to knock itself out of alignment if you hit a pothole driving down the road. So it's a challenge to try to figure out how to mount this equipment in here and how to get everything to run off the car's electrical system. We don't have generators that we can just throw on all of these cars. They're noisy, it's hard to maintain and things like that. So we have to try to design ways to run the cables and to run the power systems so that it's basically all self-contained and it's highly mobile and it's highly deployable. The other mission that this has, and you can see in the bottom here, we actually carry helium tanks with us, and this particular vehicle will also be launching weather balloons. It has 2 different sounding systems, so they can actually listen to 2 different soundings at the same time. But those weather balloons provide us the entire, lower atmosphere's information as far as temperature, pressure, wind speed, wind direction, relative humidity goes. Basically, the building blocks of what all of our forecast models are run off of. The Weather Service launches weather balloons twice a day from a number of locations across the country, and that's what every forecast model we've ever seen is based off of. But we have the ability to do those launches from point locations in the near proximity to storms to figure out what types of environments the storms are working with. How do those environments change as the storm develops and matures and moves? So they have the ability to launch weather balloons out of the back of this, so they're also going to be doing that.
So what we're doing here is an experiment called TORUS, which is a new generation of tornado experiments. Actually, what this experiment about is more about the supercell itself and how it organizes rotation in the low levels near the ground. Whether a tornado happens or not isn't so important, but just those processes that are going on in the storm, that's what we're after. And my part of TORUS has to do with these surface observations with these vehicles behind me. We drive through some of the most dangerous parts of the storm where we think the rotation is beginning to form and work its way toward the updraft and try to understand what's causing that rotation to form. There's a lot of different equipment here. The trucks with instruments on the top are called mobile mesonettes, and their mission is basically to drive through parts of the storm and make surface observations as the storm moves along. We also have mobile Doppler radars like the one behind the trucks. They'll stand back and scan the whole storm and try to understand what's going on across that whole scale. And then we also have unmanned aircraft in this project, which is the first time ever. We've always felt that we have lots of wind observations through these Doppler radars, but we have very few measurements of temperature, pressure, and humidity in the storms. So we're going to start to remedy that a little bit with these UAV aircraft. Also the NOAA Hurricane Hunter aircraft out here, which is going to fly back and forth all day alongside the storm. They have several research Doppler radars on board. Give us a whole 3-dimensional picture of the wind flow in that storm all day long.